In this video, we're going to do alkynes, so I put the general formulas in just to save a little bit of time. When we draw these out, again, I always like to connect them with a single bond to start, and then we'll add our triple in after the fact. So for the first one, the triple bond doesn't have anywhere to go. It goes there. For the second one, you could put it here or here, because again, just like I did in the last, I mentioned this in the last video but with more detail on the models. If I put it here or here, it's the same thing. You just flip the molecule and these are the same spaces. Now, when you get to 4 or more, now you have some variation. So the way you do that is I always like to think of it like this. So I'm going to put a red line, dotted red line here very lightly. And I'm going to say, all right, I'm going to put double bonds, or triple bonds in this case, in the molecule starting at carbon 1. And then I'm going to move it one to the right. And then I'm going to move it one to the right again. And once I've hit the middle of the molecule, whether that be a bond or an actual carbon, and depending on if it has an odd number or even number, it doesn't make a difference. But once I hit the middle, I have done every version of that molecule that is possible. Because if I moved it here, it is just a mirror image of this one. And if I move it here, it's a mirror image of the first one. So that's why once you hit the middle point, you've done every version. All right, now we need to number them. We don't number the first one because it doesn't matter if I call this carbon 1 or this carbon 1. If I flip it, it's the same thing. So this is just ethyne, okay? And then the next one is going to be propyne, okay? And again, whether I call it carbon 1, 2, or 3, or if I tried to number it, if I put the triple bond here, I would just call it 1, 2, 3. I would just number it in the reverse order. It would be 1 either way. Since there's no such thing as 2 ethyne and there's no such thing as 2 propyne, then I don't need a number. So a good way to explain this is like house addresses. The reason you need a house number for your house is because there's more than one house on your street. If you were like super rich and you had your own street and you were the only house on the street, turns out you wouldn't need a house number. You would just say, so let's say I win the lottery and I buy my house in the middle of nowhere and I have my own street and I call it Castle Learning Avenue. If I was the only house on Castle Learning Avenue, I don't need a house number. I just say, I would tell the mailman, deliver it to Castle Learning Avenue. Well, what house? The only house. There's no number needed. Well, as soon as I get a neighbor, so let's say a neighbor came and they were like, all right, I'm going to move next to you on Castle Learning Avenue just because they like Castle Learning so much. We would now need house numbers because the mailman wouldn't be able to say, okay, well, which house does this particular mail go to? Do I go to number 1 or do I go to number 2? And that's where these numbers come in. If there's more than one version, then it needs a number. If there's only one version, then you don't need the number. It's not necessary. There's only one version, and that's how it works. So I'm going to add the H's in to save time. I'm just going to write lines to represent H's. Okay, so for these first two, let's condense them. CH, CH, and then this one would be CH, just a C, then another C with 3 H's. Hopefully everybody understood that last part. And then for these, we'll add our H's in as well. Put an H there, nothing on that carbon, and then it's back to normal. And then for this one, 3, nothing, nothing, 2, 2, 3, 3, 2, nothing, nothing, 2, 3. So for this, it is going to, when we do our condensed, it is going to look like this. CH, that's this carbon. And then for the next carbon, it's just going to be a C. And then for the following carbon, it'll be CH2, 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 CH3. And then for this one, we've got CH3 for this first carbon. This second carbon doesn't have any H's, so we just write a C. The third carbon also doesn't have any H's, so we write another C again. The fourth carbon, CH2, CH2, CH3. And then for the last one, CH3, CH2, C, C, CH2, CH3. And then for the names, these would all be hexyne, but they're going to need numbers to differentiate them between them. So this would be 1 hexyne, 2 hexyne, 3 hexyne. One of the things that hopefully will make this a little bit easier to understand is if you look at 1 and 2, those are polar molecules, because if you draw your symmetry, they're asymmetrical. When you get to 3, it's nonpolar, and because it's symmetrical, and so polar versus nonpolar means they have different intermolecular forces, and therefore they're going to have very different boiling points, and so they will 1 and 2 will be very similar, it turns out, but 3 will be very different in terms of some of its properties. And so you do have to that's part of the reason why they need different names, because they do have different properties, because they are not the exact same structure. Their properties are often very similar, but they are different enough for us to worry about, which is why we have to come up with different names for them. And then the last one, how many bonds are in a molecule of propine? Draw it out. So it looks like that. So if I count my bonds, 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 bonds in a molecule of propine. The formula would be C3H7. So if you were to just add up 3 and 7, you'd get 10. It wouldn't work. If you try to say prop is 3 carbons, so there must be 3 bonds. That's a common mistake a lot, so you'll see a lot of that. The best way to do it is to just draw it out and then count the number of bonds. And that's everything for alkynes.